Right? A lot of people get really overwhelmed by these because there's so many rules that you have to remember. Not a whole bunch new, because you've actually dealt with radicals before. Okay? So not a whole bunch new, but you have to remember exponent rules, you got to remember fraction rules, okay, you got to remember terms, how terms work. Okay, so there's all kinds of things that you have to remember. So we're going to end up simplifying these, we're going to end up adding and subtracting these, we're going to end up multiplying and dividing these. Okay, so there's all kinds of things to keep straight. We're not going to get super far today, but you're going to be exactly in the same place as everybody else. And so that's going to be good. That means the next time we see each other, we got a lot, we'll be talking about a lot. So the first thing you want to know is all the parts to a radical expression. Okay, and so you got the index out front, the radical symbol and the radicand. The chances of me saying the word radicand more this year than right now is very slim. I usually just say the number inside, okay? But it is called the radicand. I will say index often, because that's an important part. And radical all the time. Okay, so those are the first things you need to know about.
So they're not variables.
They will not be variables usually. The radicand can.
The radicand can.
Yeah, that might be a lot. This is usually almost always going to be an actual number. Okay, now this is a square root, and you don't usually see the index on a square root. Okay, so you want to think about this as, this x, what's the coefficient with the x? 1. What's the exponent with the x? 1. Okay, but you just don't write it. It's understood. If there's no number out there, you need to understand that it's actually a 2. Okay, so that's the first thing you want to understand. All right, but I want to bust through some exponent rules real quickly, a little refresher, because we are going to need these in the long run. Okay, so let's just get these things out of the way right now. And we're only going to talk about 3, and the first one's going to be this. And so when you multiply like bases, what do you do with the exponents? That's right, you add the exponents. Exponents. We'll say it again.
It could be negative 2x.
That's times. So then it's just, we're multiplying. So n plus m. Okay? When you're multiplying like bases, add the exponents. We're going to use that rule in the long run. It might be a week or so. It might be a while before we use it, but that's something that we got to need to know. All right, so here's your example. Okay, so if we're multiplying those two things together, what would you get?
X 8 to the 8th and y to the 8th.
Okay, this is correct. And so what do you got to remember to be able to get x to the 8th?
The exponent is 1.
That's right. If it's not there, that means it's 1. So it's 1 plus 7 is 8, and 3 plus 5 is 8. Is that okay? All right, if I get too fast, slow me down. I want to make sure we get to the same spot. How it is dividing like bases. So when you divide like bases, what do you do with the exponents? That's right. Okay, and so for our example up here, that would look like x to the n minus m. Okay, and here's your example for it. X to the 7th, y to the 6th. Is that okay with everyone? Okay? So there's only one more that we're going to talk about right now. Okay, and that's power to a power. Like this. So when you raise a power to a power, what do you do with the exponents? You multiply, good. Okay, and so for our little one up here, this would be x to the nm. Okay, and here's your example. So what would this one be? And y to the... All right, is there any questions on any of those? Now the reason we need to know those is because radicals are exponents. Okay? And you can change back and forth in between those forms. And the choice would be whether it makes it easier or not. And that only way you know if it's easier is through experience. Okay? So the first thing that we're going to talk about, and we're going to go right up to the end. Okay? The first thing we want to talk about is switching them from radical form into exponential form. So let's start off with generic form of it. Okay? So if you remember this, okay, so what you notice is the index comes down and becomes your denominator. Any exponent inside becomes your numerator. Okay, and this one is radical form. And this one is exponential form. And again, they're interchangeable most of the time, the vast majority of the time. Your answer should be in radical form, unless you're specifying to not be in radical form. Is that okay? So we're going to do a couple examples so you see how they switch. Okay, so I want to change this into exponential form. There is no index visible, so that means it's what? 2. It means it's 2. Okay? Everything else is a 1. Okay? Usually, that's what you're used to saying. Right? If a coefficient isn't there, that's a 1. If an exponent is not there, it's a 1. Okay, but now you guys switch it up. And I'm going to try to explain this here in a second why this works. That's the square root. So there's actually a 2 there. Okay, so you got to remember that. All right, so this form would be x to what then? 3 over 2.
Why is there 2 there?
I'm going to try to explain that here in a second. Okay, I haven't really got to that part yet. Okay, but let's just let's just switch a couple just so we know what's going on. Okay.
So the index part is the denominator?
That's correct. Right, the index becomes the denominator of your exponent. Any variable inside becomes the numerator of that exponent. Okay, so here's another one. What does that become? X to the 1 over 2. Okay? All right, we're gonna talk about how you say these things also. So get one like this. Okay, this is said the 10th root of x, and you could say cubed, but just for illustration, right, x to the third. That's how you would say it. Okay, and that's important because I will start saying those things. And it's very important that if you forget that you say, what the heck are you talking about, old man? Right? Don't just let me keep talking. You're just like, okay, because this stuff builds up real quickly. And if you can keep up, it's not a big deal. But if you can't, this is really a tough section. Okay? There's so many rules that you got to keep straight as we go. So you definitely slow me down. But change this to exponential form. And what is this?
X to 3 over 10.
And that's how you say it. X to the 3 over 10. That's a good way to say it.
Could you say index instead of root?
I would know what you're talking about. Okay, so if you said the index is 10, I would understand what you're saying. I won't say that. I will say the 10th root or the 5th root or the nth root or whatever. Okay.
It's just like the radicals, the square root, we've dealt with square roots
Right.
too. That's why the index, if there's no number there, is 2 square. And then we've sometimes have mentioned cubed root, so we'll be getting to that. So that's why that 10 is called a root per se.
Right. That's exactly right.
So then basically wouldn't the exponent be like a fraction, right?
So the exponents are always going to be a fraction unless they simplify away, and I'm going to try to get to that.
Yeah.
But yes. Okay, so once you have a radical sign, your exponent is a fraction. Okay? It's very important. All right, so let's talk about the square root thing. Okay? And then hopefully this will make sense, and this will be probably the last thing we really talk about today. So, here, let's just write down. What is the answer to that?
9 and 2.
You're going backwards.
9 and 2 over 1.
No. What is the answer? You did the opposite way. It's not 81.
1 over 2.
No. I'm not doing that. It's just 3, right? This is 3. Everyone knows that, right? Square root of 9 is 3. So what the heck is a square root telling you?
A number by a number equals that.
What times itself gives you whatever's inside. Okay, so what times itself? 1, 2. Times itself, 2. Square root. That's why the index is 2, because we're grouping in 2s. We're looking for a group of 2 factors that give you that. Okay, but some of you guys were trying to switch this to the exponential form. So what would this look like in the exponential form?
9 to
1 over 2. So go ahead and type that in your calculator. Raise 9 to the 1/2 power. And it better give you 3. Because they're interchangeable. Okay? Well, that's okay. If you're getting 4.5, you better watch where you got the old one. You got to put it in parentheses. You guys with the new ones, it should just pop up there and you can put 1 over 2. But if you have an old calculator, you better use parentheses when you do your exponent, okay?
I got 3 now.
All right, now. I'm going to go about this the long way because you guys maybe you won't understand why, okay? But we're not dealing with square roots all the time here, okay? I would bet that most people here know the square roots of the following numbers. Square root of 4, 2, square root of 9, square root of 16, 4, square root of 25, square root of 36, 49, right? Okay, so 64, etc. So we all know these. Okay, so now let me ask you this. What's the cube root of 27?
Cube root?
Yeah. No. He's on the right track, though. But that's my point,
Right.
okay? My point is you probably don't know your perfect cubes. Perfect cubes are 8, 27, 64, and I don't want to know anymore. I think it's 125, okay? So you got to have a way to attack these, because we're only doing square roots just as an introduction. And then we're going to do cube roots, 5th roots, 10th roots. And so you have to have a way to be able to understand what's going on. All right?
So if there's not like a variable or a number in the index, it's always going to be 2, right?
That's right. There's no number in the index, it's 2. This will be the last thing. I got a couple minutes. We're going to bust through this. Factors of 9 are what? 3 and 3 if you're doing this factor tree, right? Okay? So then 9 can be written as 3 to what power? The second. And then if I drop this 1/2 down, what's our power to a power rule?
What do we do with the exponents?
You
Multiply them, so what's 2 times 1/2? 1. So this is really 3 to the first. Okay? Or, and this will be the last thing I say, or the other way to think about that is, like you look at this, and you say, I need to group factors in groups of 2. Here they are. There's one group of 2 3s. That's why it's 3. Right? It could be there, or it could be like that. Okay?
Is 3 to the first power the same thing as 3?
Listen, everybody listen.
Yes.
Wait a minute.
Listen, don't move.
Right? 3 to the first power, is that the same as 3?
yes.
Yeah, because right, you just don't write the 1 exponent anymore. I need somebody by Monday to remind me exactly where we left off so that we can pick up there, because we got a bunch to talk about. There's a bunch going on here, okay?
Guys.